There are moments in astronomy when nothing dramatic appears to happen, and yet the overall picture quietly begins to shift. Not because of a single image or a striking measurement, but because several small details start aligning in a way that feels different from before. With 3i Atlas, we seem to be entering one of those moments. The object itself has not suddenly changed course, nor has it produced anything spectacular. And yet, the way it is behaving is beginning to suggest a transition into a more active phase. Subtle enough to miss at first glance, but consistent enough to draw careful attention. Over recent observations, astronomers have been tracking small variations in brightness and structure that appear more organized than earlier measurements. These changes are not abrupt. They unfold gradually, almost cautiously, as if the object is responding to conditions it has only recently encountered. Nothing here points to instability or danger. What it points to is motion, interaction, and adjustment. The quiet mechanics of a body moving through a new environment. If you value calm, careful explanations of how scientists interpret these kinds of changes in space, you may consider subscribing for more thoughtful, evidence-based observations like this. What makes this phase interesting is not the scale of the activity, but its timing and consistency. Earlier in its trajectory, 3i Atlas appeared relatively inert, with behavior that fit comfortably within expectations for an interstellar object passing through the outer regions of a star system. Now, as its orientation relative to the Sun continues to evolve, the object is receiving energy in a way it has not experienced for a very long time. That energy does not arrive evenly. It falls across surfaces, angles, and materials that may respond differently depending on composition and structure. There are moments in astronomy when nothing dramatic appears to happen, and yet the overall picture quietly begins to shift. Not because of a single image or a striking measurement, but because several small details start aligning in a way that feels different from before. With 3i Atlas, we seem to be entering one of those moments. The object itself has not suddenly changed course, nor has it produced anything spectacular. And yet, the way it is behaving is beginning to suggest a transition into a more active phase. Subtle enough to miss at first glance, but consistent enough to draw careful attention. Measurements indicate that the light reflected from 3i Atlas is changing in a smooth but noticeable pattern. These variations are not random flickers. They appear coherent over multiple observation windows, suggesting rotation combined with surface features that are beginning to interact more actively with solar radiation. This is often how activity begins, not with a sudden outburst, but with a slow rebalancing as heat penetrates layers that have remained cold for extended periods. There is also growing attention on the faint structures surrounding the object. These features remain extremely subtle, close to the limits of what current instruments can resolve. They do not resemble large, dramatic tails or jets. Instead, they suggest a restrained release of material, possibly gas or fine dust, responding to gentle warming rather than violent disruption. Such behavior is consistent with early-stage activation, where internal pressures are still low and surface layers remain largely intact. It is important to be clear about what this does not mean. An active phase does not imply instability. It does not suggest fragmentation. And it certainly does not point to anything artificial or unexpected in a fundamental sense. Many natural objects exhibit phases like this as they move through changing thermal environments. What distinguishes 3i Atlas is not the activity itself, but the fact that it is happening in an object whose origin lies far beyond our solar system, shaped by conditions we can only partially reconstruct. Scientists are therefore approaching this phase with restraint. Rather than rushing to interpret every fluctuation, they are comparing these new measurements with earlier baselines, looking for continuity rather than surprise. The emphasis is on pattern recognition. How quickly the changes progress, whether they stabilize, and how they correlate with orientation and distance. Each of these details helps narrow the range of explanations without forcing a conclusion. There is also an awareness that interstellar objects may not behave exactly like the comets and asteroids we know well. Their materials may have formed around different stars, under different radiation environments, and over timescales that stretch far beyond familiar models. An active phase in such an object may follow rules that are similar, but not identical, to those we have cataloged before. At this stage, the most responsible stance is patience. Continued observation will determine whether this activity increases, stabilizes, or fades as conditions change. Each possibility carries different implications, and none of them require speculation. They require time, consistency, and the willingness to let the data speak slowly. This is where we pause for now, not at a conclusion, but at a moment of attentive watching, where the object's behavior invites understanding rather than answers. As observations continue, attention naturally shifts from what appears to be happening to what might reasonably explain it. In cases like this, scientists begin by asking the simplest questions. How does the object's activity align with changes in solar exposure? Does the pattern remain stable over time, or does it drift as geometry changes? And, perhaps most importantly, are these behaviors consistent with known physical processes, even if they originate in an unfamiliar context? One interpretation under consideration is that 3I Atlas is entering a phase where volatile materials near its surface are beginning to respond more noticeably to warming. These materials do not need to be abundant to produce subtle effects. Even small pockets of gas, released gradually, can alter brightness profiles and create faint surrounding structures that only become visible under careful analysis. In this view, the activity is not sudden or dramatic, but delayed, the result of heat slowly penetrating layers that have remained insulated for an exceptionally long time. Another possibility relates to surface texture and shape. If the object has an irregular form, certain regions may receive concentrated energy as its orientation shifts. This can produce repeating patterns in reflected light that mimic changes in activity, even when material loss is minimal. Distinguishing between true outgassing and purely reflective effects is challenging, especially at great distances, and it requires repeated measurements taken under slightly different viewing conditions. What remains notable is how restrained the signals are. There is no evidence of chaotic motion, no abrupt changes in trajectory, and no signs of instability. The object continues along its path with remarkable consistency. Whatever activity is occurring appears to be governed by the same physical principles that shape many natural bodies: energy input, material response, and gradual adjustment, rather than sudden transformation. Equally important is what scientists are not seeing. There are no strong emissions that would suggest high-energy processes. No irregular accelerations stand out against gravitational models. And no single observation forces a departure from established physics. This absence of extremes is not disappointing. On the contrary, it provides a stable framework within which careful interpretation can take place. As more data accumulates, researchers will be watching for changes in rate rather than magnitude. Does the activity increase smoothly, or does it plateau? Does it correlate more strongly with orientation or distance? Does it fade as quickly as it appeared? These questions cannot be answered by a single image or measurement. They require continuity, the patient layering of observations over time. In this sense, the current phase of 3I Atlas is less about discovery and more about refinement. Each new data point slightly sharpens the picture, not by adding drama, but by reducing uncertainty. This is often how progress unfolds in astronomy. The most meaningful insights rarely arrive as sudden revelations. They emerge quietly, through consistency and comparison. There is also a broader context to consider. Interstellar objects are still rare in our records, not because they are uncommon in space, but because detecting them is difficult. Each one we observe expands our understanding of what material from other star systems can look like when it passes through ours. Even modest activity in such an object carries value, because it informs models that have very little empirical grounding so far. For now, 3I Atlas remains what it has always been, a distant traveler, revealing just enough to invite careful study, but not enough to resolve every question. Its apparent move into a more active phase does not demand reinterpretation of what it is. It simply reminds us that motion through space is never static, and that interaction, however gentle, leaves traces worth paying attention to. As the observations continue, clarity may increase, or it may remain partial. Both outcomes are scientifically meaningful. What matters is maintaining the discipline to observe without projecting, to interpret without rushing, and to accept that some answers arrive slowly. If you find value in this kind of calm, evidence-based reflection on what we observe in space, you are welcome to join the conversation by sharing your thoughts, and consider subscribing for future explorations that favor understanding over speculation.